now come to the next topic, and the next topic is your virtual functions. So how we can implement this virtual function and what are the virtual function. So first of all, I'm just going to discuss about what are the virtual function and how we can use these virtual functions in our C++. So this is your virtual function. So first of all, what is virtual? As the name suggests, that is virtual is something that exists in effect but not in the reality. So this concept of the virtual function is same as that of a normal function, but it doesn't rely or really exist in the existence in a program. So the object-oriented programming languages C++ generally implement the concept of a virtual function as a simple member functions like all other member function of the class. Now, how this concept comes into the existence of the virtual function? As the concept of polymorphism is there, and what is the polymorphism? Actually, poly means many and morphism means forms. So we can have the many forms of the same thing. So they in case of a polymorphism, we have generally two types of a concept. First one is your function overloading, that is use of the same function name for the different purpose. Second one is your operator overloading, again use of the same operator for the different purpose. So we have these two topics that comes under the polymorphisms. Now C++ virtual function, you can say that, is a member function of a class whose functionality can be overridden in its derived classes. Now before moving on to this, the concept of a virtual function, I just want to tell you the some properties of the virtual function. The first properties of the virtual function is, that is, in case of a C++, it is a member function of a class. Second one, that is, it declared with the virtual keyword. It is declared with the virtual keyword. Third one, that is, usually has a different functionality in the derived classes. That means it doesn't behave like a normal function because we are assigning it the virtual with the virtual keyword. So usually it has a different functionality in the derived class, now fourth one, that is your a function can be resolved at the runtime. That is the most important thing. Function call is resolved at runtime. Now as the name says runtime, that means these virtual functions can be only be called at the runtime during the execution of the program. So the functionality of the virtual function can be overridden. It's the derived classes, and this is the virtual function. We can call it as a mechanism to implement the concept of a polymorphism. The ability to give the different meaning to this one function is called virtual function. So virtual function is a mechanism to implement the concept of polymorphism. And how it is achieving this polymorphism? This is achieving during the runtime. Now when we are talking about the polymorphisms that we can achieve at the two times, the first one, polymorphism can be achieved at first one, that is your compile time. Second, that is your at runtime. Now when we are talking about this concept in case of a compile time, we have the two types of overloading, and that is called, first one is called function overloading and second is called operator overloading. So that both comes under the compile time. This function overloading comes under the compile time, and operator overloading also comes into the compile time. Now when we are moving on to this runtime or polymorphism, that means we can achieve this polymorphism and at runtime with the help of, that is called with the help of virtual function. Virtual function, that is the most important concept of the C++. So let us we understand about this, how we can achieve polymorphism at runtime with the help of virtual function. I just want to tell you, when we use the same function name in both the base and derived classes, the function in the base class we can declare as a virtual. When the function will be made as a virtual, the C++ compiler automatically determines which function is to be used at the runtime based on the type of the object pointed by the base pointer to the point to a different objects. So that's why I have firstly discussed about the topic. The topic was your casting base class pointer to the derived class pointer, because that concept we are going to use in case of a virtual functions. Now how we can use this concept, again going to repeat it. The C, when the function is made virtual, the C++ determine which function is to be used at runtime based on the type of object pointed by the base pointer to point to the different objects, to the different objects. So that's why we need to discuss about the casting of the base class pointer to the derived class. So I'm just going to take a simple example of this virtual function. So how we can declare this virtual function here and how we can use this. So first of all, what I need to do, I just need to make the some class here. So just a second, I need to create a class here. So this is now this one, yes. So first of all, I am going to just declare a normal program without using virtual function. Then I will show you how we can make the virtual function a one class and then how we can use it. So first of all, what I need to do, just I need to define here hash include IO stream header file. This is IO stream. Then hash include, I'm taking here the conio header file, that is a conio.h. Then I can take here the namespace using namespace std. Then what I need to do, I just need to take here the class. So I'm going to create here the class, that is your base class. In this base class I'm going to define a normal function, that is your void and then display. This is void and this is your public. In this void display I'm just going to only printing here the cout display derived. This is a slash n and double quote slash n display derived, then terminated. Now I'm going to declare the another function. This is a void and void show. In this void show, that is your show derived. This is cout and this is cout double slash n and then show derived, and then I'm going to close this class. So I have closed this class, base class I have been closed. Now I am moving on to this main function. This is, I need to just create the derived class also. So I'm just going to create the derived class. This is your class D, which is going to be publicly inherit public and then base class, that is your P. Now this is, I'm going to declare here same methods, that is your derived. So I need to take here the another two function. This is public. In this public I'm going to declare the one method, the same method I'm going to take, that is a void and display. In this void display I'm just going to write here cout, and this is your derived class. So I have taken here the derived class. I just need to change here the display base. This is your base. Similarly, display base. Similarly, I'm going to take here the show base. And for this derived classes, what I'm going to use, just I'm going to take here the derived class. Then another function I'm taking void show. In this void show, I'm just going to write here cout, and then this is your derived show. Then we have close it, then closing the class here. Now this is the main function, void main. In this main function I'm going to declare here the object here. So first of all I need to create the base class object. So this is your base class name, and then object name is b. We have taken the derived, and this is your d, and I'm just going to create the base class pointer, that is your bptr, then cout, bptr points to the base, bptr points to base. Then what I'm going to do, just I'm taking here the bptr pointer and pointing the address of b here. Then with the help of this bptr I'm going to display here the function. Firstly, the first function was display, calling the function display. Then with the help of bptr I'm just going to call another function, that was the show. So now what function it will call, because we have created here the base class pointer, and we have passed the address, that means address of the object of the base class. So ampersand b we have passed here. So it will call the base version of the function display and show. Now what I'm going to do, I'm just going to pass the address here. So suppose this is, I'm taking here the bptr equal to ampersand d. That means I'm passing the object address of the derived class. So this is the derived class object, and passing it to the same pointer, that is a base class pointer. And now I'm going to calling the function bptr, and that is your display I am calling. So this is display I am calling here. Similarly, with the help of bptr I'm just going to call the another method, that is your show. So again it should call the derived class method display and show, but it will call the base version. So that is the problem that comes during the multiple inheritance, because we have defined the same name of the methods in both derived class as well as your base class. So when we are going to call the base class pointer to the method of the base class, then again calling the base class method display and show. When we are going to pass the address of the derived class object, then going to call the display and show, again it is calling the base class method display and show, not the derived class method display and show. So this kind of a problems generally arises in case of a multiple inheritance. Now how we can solve this kind of a problem? With the help of virtual functions. So how we can do that? I just need to define here the virtual in front of any one of any two functions of the base class. Suppose what I'm going to do, I'm just going to taken here this base class is there. So I'm just going to define here virtual. I'm going to use this virtual keyword, virtual void display. Similarly, I'm going to use here virtual void, this is virtual void show. So what will happen here, this virtual will make or bypass this your base class methods. Now when I'm going to do, I'm just going to calling this with the help of this drive class, passing the object of this one. So now this will call the drive class method display and show here. So in the class, the base class, when we have declared show and displays virtual, then when virtual keyword precedes the function definition and the same function is overridden in the drive class. Now we are going to execute, that means we are going to calling the display and show, passing the drive class address of the objects. So in this case it will execute runtime system and doesn't check the type of the pointer, instead it check what type of object address we have passed. So what type of object we have passed here, we have passed the address of the drive class object to the base class pointer. So now it will check the address of the drive class object and call the method of the drive class display and show. But sorry, when we are going to passing the address of the base class, then it will check, that is what type of object address in the pointer contains. So it is containing the base class address of the object, so it will call this the method of the base class display and base class show. So that is the use of the virtual function in case of a C++. So when we are going to use this concept of multiple inheritance, we generally use the concept of a virtual function. So that is the most important concept in the C++. And so today we have discussed the mainly two topics that are most important topic. The first topic we have discussed about the your casting base class pointer to the derived class pointer, because before understanding the concept of your virtual function you must need to know how we can pass how we can create the pointer to the base class and how we can pass the address of the object or base class as well as the derived class, and how we can cast the base class pointer to the derived class pointer. So that was the first concept that we have discussed. Then we have discussed about the second concept, that is your virtual function. So without virtual function we have discussed about how we can create the two classes, and without virtual function what function of the base class or drive class will be called. And when we are going to use this virtual function, it resolve the problem of the multiple inheritance. So it automatically resolve by pointing to the objects of the base class and derived class. So when we are going to use this virtual function, it generally cannot generally it cannot be focused onto your pointer, that is a bptr. It generally focus on the address of the object we are passing it. Suppose we are passing the address of b here, so now it will point to the display and show of the base class methods. When we are passing here the address of d, that means now this bptr will point to the display and show of the drive class methods. So now before winding this one, I just want to tell you about the properties of the virtual function. First of all, virtual function is a member function of a class. Second, it is always declared with the virtual keyword. Third one, it usually has a different functionality in the drive class. Fourth one, a function call is resolved at the runtime. Now these concepts comes under the polymorphism, and we can achieve this polymorphism with the help of uh, two times, that means compile time at or as well as runtime. So compile time, in case of it we are going to achieve polymorphism with the help of two types of overloading. That first one is called function overloading and second is called operator overloading. Now how we can achieve this polymorphism at the runtime with the help of virtual function. So that was the most important concept of the C++. Thank you.